Hi people, welcome back to the next lesson. It's section properties. There's a document I put on Blackboard. It's called section properties, some notes. That's what it's called, section properties, some notes. I put in a note a few pages from a textbook which some of you have seen already. There's about 6-7 pages there. I don't want you to go through all these details, so that's the next topic. Section properties. Now you've already got this table here. I've given it to you. It's called section properties of some common shapes and sections, something like that. Okay, so there's it coming again. And when we did the famous bar x bar y, if you remember, we did the famous bar x bar y, we used the table to find where the centroid is sitting. Okay, for the rectangle, for a triangle, for a circle, and for a semicircle. Okay, so we've done that already. So there we go. So the first bit, the first property that we're going to determine of a cross section is determining bar x bar y, which we already done in applied mechanics. And as I told you already in the beginning of this, I think it was last week in the first lesson in the introductory session for this for TOS, was that this is the one section we're gonna take from applied mechanics and just expand on it quite massively. Okay, so the first section property we can determine is the position of the centroid. Okay, now if it's a simple shape like a rectangle or a square or a triangle or a circle or a semicircle, we know where it is. Okay, so bar y would be half of d. If I just make this bigger. Okay, bar y would be d over 2, because from there to there and from there to there will be the same. And for the triangle, it's 1/3 from the bottom and 2/3 of the depth up. And of course for a circle, it's dead in the middle. Okay, but because a circle is special, the distance from there to there, we call it the radius, which is d over 2. And of course, if we have a semicircle like so, I'm just making it big so you can see it nicely. We saw that the distance bar y from the gravity to there is 4r over 3 pi. Okay, you know that by now. So the first property that we can determine is the bar x bar y. Okay, I'm just going to briefly just talk about it. Okay, but I'll point to this document in detail as we go through section properties. The next thing we're going to do, there's the famous formula. Bar x is the sum of all the area times the x distance over the total area, and bar y is the sum of the area of each element multiplied by each y distance over the total area. Just little different symbols, but it's the same thing, you know about it already. Right, the next thing, the big thing that we're going to be looking at is what we call the second moment of area. Okay, now when we worked out this, when we worked out bar x bar y, sorry, we took the area and we multiplied it by a distance. Now if you cast your mind back, what's the definition of a moment? It's a force multiplied by a perpendicular distance. When we did bar x bar y, we took an area and we multiplied it by a distance. There we go. Okay, so we took moments of areas. We took an area and we multiplied the area, we multiplied it by distance from its centroid to a point or line we took moments about. Okay, so that was moments of areas, and we call that the first moment of area. Okay, and if we take that area and we multiply it by its distance, okay, it's the first moment of area, and we multiply it by the distance squared, we get the second moment of area. Okay, so, and there's the symbol for second moment of area is actually capital I, but if I just look at that symbol over there, we read that thing as the second moment of area about the x axis, and the other one is the second moment of area about the y axis. Okay, and the x axis is normally horizontal, and the y axis is normally vertical, which is right angles to each other. So those two axes are always at right angles to each other. That's all I'm going to say about it for the moment. Okay, there's lots of mathsy bits there. You can go through it if you want to, but if you don't, that's fine. I'm going to discuss this in detail in the next lecture when I work through an example. And then the next thing we call what this author calls it the parallel axis principle. I also call it the parallel axis theorem. It's also known as the parallel axis theorem. There's the formula, but the one which I'm going to use is that there is Rxx is equal to the sum of, and there's a big square bracket there, it's Rxx, which is the second moment of area as we know it from the table, which is that over there. I'm going to refer to it as I do it. Okay, so Rxx is equal to, so notice there, big X, small x, it's not the same thing. Okay, I'll point it out when we work through an example, plus the area of the element as you know it times the distance squared. And then I say there, see the separate note about the second moment of area, and that other note is actually this one over here, which is also in the folder under section properties, and I think I am going to explain it more over there when I do an example. Okay, so that's the other note. That's the other note I'm referring to over. When I say see separate note about second moment of area, it's the other note over here. Okay, right, I'm going on. And then the next thing there we're going to look at under section property is the radius of gyration. There's the formula. Small r is equal to square root of I over a, where I is the second moment of area, as I just explained a few minutes ago, divided by the total area of the cross section, which we already learned to determine in applied mechanics, but I'll explain this as we work through it. And then the last thing we want to look at under section properties is the elastic section modulus, or just section modulus, and its symbol is Z, sometimes a big Z, sometimes small z, and there's the formula for it. Z is basically second moment of area divided by bar y, which we learned to determine in applied mechanics. Okay, but because there's two axes, zxx and zyy, there's two sets of section modulus. Okay, so people, so that's the full document under section properties and more notes. So the first thing, just to recap, the first thing we're going to do is work at the famous bar x bar y. Then we're going to work at the second moment of area, Rxx and Ryy. And once we're done with that, we're going to work at we're going to actually do this calculation using the parallel axis theorem, which is that formula there. And then once we're done with that, we're going to work at the radius of gyration about the xx and the y axis. So that's another two sets of calculations. And then we're going to work at the section modulus, which is going to be zxx and zyy, which is another two set of calculations. But the real biggie is determining that thing over there. And to get it right, a lot of people struggle with it. But that's the biggie. Once we get past this, from here, the others here is just using what we already know. It's the easy bits. Okay, so people, that's just an introduction to section properties. As I said there, we're gonna, when we do an example, we're gonna first work at bar x bar y, which is that over here, which is what you know from applied mechanics, and then we're going to span of that massively to work out the second moment of area, to work at the radius of gyration, to work at the section modulus about the xx and the y axes. Okay, but I'll do that in the next lesson. I'll pull up this document, I'll refer to it as I go. I'll also refer to this document as I go when I get to second moment of area. So people, that's just an introduction to second moment of area, and I shall see you in the next lesson.